this computer. There you go. Okay, so for your homework, you had to look for, in the first part, you had to look at 3 statements and determine whether the statements were believable, whether you thought that there was a bias in the statements, and whether they had been chosen by the company on which the statements were made. And a lot of you had the right intuition, which was basically to say, okay, this is one experience. It gives us one point of view. Based on the point of view that we get, we can determine whether the company chose that point of view or not. If the point of view was beneficial to the company, then it was probable that the company had chosen it. And if not, then the company probably didn't choose it. But we can't really draw conclusions on whether the company is good or bad based on those statements, because it's just one experience of a possible many experiences, right? And that's because it was just one anecdote and not a collection of them. So it just gave one perspective on what could happen with that given product. For the second part of the homework, you had to look at 2 articles. The first one was about the miracle at a cafe, which was about a so-called miraculous drink. And then the second one was about trophy hunting and how introducing regulations on trophy hunting can actually be an incentive for conservation activity at given countries, right? And again, most of you had the intuition that, you know, data, that articles that were based on data and that were based on studies were more reliable than articles that were not based on data, just because they collected a variety of different topics, and because in collecting that variety of different experiences and sources, you might have included all the possible variability and are actually evaluating typical experiences. A couple of comments that I wanted to make about this is that anecdotes are actually not necessarily bad. The problem is that when you have anecdotes, you need to make sure that they come from different sources, right? So what that means is that you can collect data based on anecdotes. So you can have a collection of data in which the data is qualitative and it's based on anecdotes. But what's important is that you collect that data in a sample that is representative of the population that you're interested in, right? A lot of you talked about the fact that collecting anecdotes might be tricky because you have that anecdotes are inherently biased, so that people are going to provide anecdotes if their experience is either really, really good or really, really bad, and you don't get any of the middle. Whereas data is collected systematically on a specific group of people. Whether that data is extreme or not, we don't care about, and so we are more able to determine typical experiences. Okay. The last part was just about you talking about whether it was better to use data or anecdotes in order to study whether social isolation resulted in better or worse physical health. And most of you mentioned that you would prefer to collect data. And even those of you who said that they would prefer anecdotes said that you would prefer anecdotes collected on different people. And so if you're collecting anecdotes on different people, you're essentially collecting data, right? So it's information that is collected on a given sample, and so it's data as well. So everyone was in agreement that if you wanted to draw conclusions for a given population, you needed to collect information from several people with different experiences. All right, so that's kind of just the summary of what you were asked to do in the homework. The answers that I got, I'm pretty satisfied with the answers that I received. I think all of you got the point, which is, you know, anecdotes are great and everything, but they're not necessarily the best representation of what can be happening in a given population. So today, what we're going to be focusing on is how we can collect that data. And in order to do that, I'm going to start by introducing 2 concepts that you probably have already heard about, which are causation and association. So association and causation. Okay, so we have association and causation. Now, can anybody tell me, what association is and what causation is, or what the difference between association and causation is. Anyone? Okay. Anyone, what is association? What is the difference between two variables that are associated and two variables that are caused by one another? Johanna, you have your hand up, and I don't know if that's accidental or not.
Yeah, that's accidental. Sorry.
Okay. It's fine. Anyone that would like to give some input on the difference between association and causation? Guys, I'm literally talking to a screen. You can do me the favor of trying to answer something.
Well, isn't causation like that it's like a chain reaction type of thing? So like one causes the other, versus association is like they have some sort of link between the two.
That's exactly it. So when you have causation, you have basically one that comes first and the other one that happens because the other one happened or because the other one didn't happen. Whereas in association, you just have two things that are linked to one another, but you can't really determine whether one of them causes the other causes the one, or maybe both of them are caused by a third variable. Okay, so that's what we're going to start with today. So when we talk about causation, we're talking about a cause and effect relation, right? So what that means is that one variable is caused by another. Of course, that's why it's called causation. An example of variables that are related to causation could be, for example, the temperature outside and the number of people that are wearing sweaters, right? Number of people that wear sweaters. So presumably, if the temperature outside is higher, then fewer people are going to wear sweaters, whereas if the temperature outside is lower, then more people outside are going to wear sweaters. Then you have variables that can be associated without necessarily one of them causing the other. So when we talk about association, we're talking about when the values of two variables follow a given trend, right? And it's not necessarily clear whether one of them causes the other causes the one, or both of them are caused by a third variable. Or maybe just, you know, it's random that they're associated with one another. So one example of two variables that are associated but do not cause each other are the amount of ice cream that is sold. Ice cream sold in a day, and the number of sunglasses sold in a day, right? And these two are clearly associated because if there's more sun or it's warmer, then more glasses are going to be sold and more ice cream is going to be sold. But it's not necessarily because more ice cream is sold that you're going to have more sunglasses that are sold, or because you're selling more sunglasses, then you're going to be selling more ice cream. Does everybody understand that? You can say, yes, I hear you. Okay,
Yes.
Good.
No, not really.
All right. Not really?
I'm like confused on how like they're different.
Okay, so the difference between the two of them is that over here you can actually say, because the temperature outside was higher, let's say, then fewer people wore sweaters, right? In the second case, you can't really say, okay, more ice cream was sold, and therefore, because there was more ice cream that was sold, then more sunglasses were sold, right? It's just something that happened at the same time, but it's not necessarily something that happened because more ice cream was sold. Does that make sense?
Yes.
More or less? Okay. So it's just basically two things that can be associated with one another. They can be, you know, two things that have a certain link, but it's not necessarily a relation of causation. So in this case, the actual cause for both would be warm weather, warm and sunny weather. Right? So that's the actual reason behind it. And this is causing both of them, but it's not that the ice cream is causing the number of sunglasses sold or the other way around. Okay? So in statistics, we are often trying to show the fact that one of the variables is causing the other. So ideally, that's what we would like to show in a given situation. We would like to say, okay, this variable is causing this variable to be higher, to be lower, and so on. But that's not always that easy. So what we're going to do today is to start by looking at how causation is different from association, and then look at some ways in which we can show either causation or association. So here are 4 headlines. So stop global warming, become a pirate, lack of sleep may shrink your brain, early language skills, reduce preschool tantrums, and dogs walked by men are more aggressive. So based on these 4 statements, what I want you to do is to answer the questions that are written on the right. Oops. So answer these questions. So what is the headline implying? So basically, what do you interpret this headline? What is it saying? The second thing is, do you think the headline is implying causation or association? So this is an exercise in identifying which of the two it is. Third one is specifically in the statement, what is showing that it is causation or that it is association. And then if any of the statements is a causal statement, so that means if any of them is implying causation, I want you to try to rewrite it in a way that doesn't imply causation, that is just implying association. Okay, so you have 4 minutes in order to do this. So answer the 4 questions, rewrite the statements in terms of an association link and not a causation link. We're going to change the statement in a way that makes a little bit more sense, which means, of course, it doesn't seem like becoming a pirate is actually going to have any effect on global warming. So if I want to actually express how these 2 variables are associated, I might have to write it as an association instead of a causation. So how could I rewrite the statement in a way that implies association and not causation? Anyone? You're definitely not this shy when you're live.
I didn't understand how you could change this into a different, I didn't understand how to change it from causation to association, because do you have to change the 2 variables, or how does that work?
No, so all that I'm asking is to change the statement in a way that doesn't imply causation anymore. So for example, I'll give an example for this one, maybe that will make it clearer. And then for the other couple of statements, it should be a little bit easier to do. So for example, here I could say something like global warming is linked to the number of pirates. Yeah. All right, so that just means global warming is linked to the number of pirates. Now, what the headline was implying was that because one of them increased, the other one would decrease. But in this case, I'm only saying, okay, there seems to be a link between global warming and the number of pirates. Does that make sense? A little bit more, Caroline?
Mm-hmm.
Yeah, okay.
Yeah, that's good.
Okay, okay, so now for the second one, again, we have a statement that is implying something. Is this implying causation or association?
Causation.
Causation. So how do you know that it is causation, not association?
Because doing one thing can like lead to shrinking your brain.
Exactly. So the word shrinking means that because of one of them is changing, the other one is actually having an effect on the size of the other, right? Now, if we wanted to rewrite this as an association link and not as a causation link, how could I rewrite the statement? So if I wanted to make a more appropriate headline.
Can you say like the amount of hours that you sleep leads to the size of your brain or something like that?
So if you use the word leads to, that's already implying causation, right? So leads to is not really the phrasing that we want to use. How else could we express this? Amount of hours that you sleep, that's a good start. So the number of hours that you sleep, and then what can I say?
Is linked to the size of your brain.
Is linked to the size of your brain, or is related to the size of your brain. And basically all that that's saying is there seems to be a link between the two variables, but it's not necessarily one of them that causes the other, right? So what we're trying to do is get rid of the idea that one of them causes the other. Does that make sense for everyone?
Yep.
Okay. Okay, so you get the gist of it for the third of them. We also have a causal link, right? We have reduce, which basically means that if one of them increases, the other one decreases, and if one of them decreases, the other one increases. So there's like an inverse association with these two things. And this is assuming that the language skills are the reason why the tantrums are reducing. Now, if we wanted to get rid of that causal link and instead just consider the possibility that maybe there's just an association, what we could say is that early language skills are associated with fewer, like with a low number of preschool tantrums. Right? And so in not considering this as a causation link, what we're doing is we're saying, okay, maybe it's because there's early language skills that the tantrums have decreased, but maybe because the tantrums have decreased, the early language skills are being developed better, or maybe it just so happens that another variable is affecting both the language skills and whether or not there is a preschool tantrum. And that relation is in the same, is of the same way for both of them, but they're both being caused by something else, right? So that's another possibility. And then for the fourth one, again, what this is implying is that if a man walks a dog, then the dog is going to be more aggressive. Of course, that's not necessarily the case. And if we want to rephrase this as an association, we could say that the likelihood, for example, of a dog being aggressive is associated with the sex of the person that walks them, it, let's say. Okay, so what that means is you know, there seems to be an association between these two things. Now, we don't necessarily know if the dogs are more aggressive because they're being walked by men, or maybe because the dogs are more aggressive, that's why men are walking them, right? So maybe because the dogs are more aggressive, those are breeds that are chosen mainly by men, and that's why the men end up walking them. We don't know if this is the case. I don't know if this is true, if the relation is in one way or the other, but this is the possibilities that we have for these two variables being linked. Does everybody understand this?
Yeah.
Yeah, okay, good. So what we're going to talk about in the next part is how we can show association between, how we can show causation between two variables. And in order to do that, I'm going to ask you to watch a clip from Mythbusters. Okay, so while you watch the clip, I want you to think about these three questions. And in order to watch the clip, there's two possible ways that you can do it. You can, on Teams, so let me just share my screen. Yeah, so on Teams, you have a couple of tabs over here that say, is yawning contagious? Both of them are the same information. So just pick one of them should work, at least one of them should work. You can watch the clip. It's about, what is this? It's about 4 minutes. So I'll give you maybe 6 or 7 to allow for the clip to load. And while you're watching the clip, I do want you to answer the questions that I just put on the board. So I'm going to go back to the board that I had. Okay. Is that clear for everybody? What do you need to do? Yeah.
Yes.
Okay, good. So watch the video, answer the 3 questions. Once you're done watching the video, you can raise your hand on Zoom. If your connection is not strong enough to both watch the video and remain connected on Zoom, you can leave the meeting while you watch the video and then log back into the meeting. I'll let you in once you're done. Okay, and as soon as you come back, you raise your hand so that I see everyone that has seen the video. I'll give you 6 minutes to watch the video, answer the questions, and then we'll start talking about it in class. All right, so first question is, how did the Mythbusters design the investigation? Anybody that want to contribute something here? I'm gonna ask you all to unmute, unless you have anything else going on, please accept to unmute, and then you can answer the question. All right, so anybody, how was the study conducted by the Mythbusters? How did they design the investigation?
They made everyone go into like separate rooms.
Mm-hmm. Okay, so everyone, absolutely everyone?
Well, they like asked people to go in rooms and
Mhm.
like yawned before, and then
Okay.
like there was a camera in there. And they like saw if people were yawning.
So they creeped up on people while they were waiting in a room board. And for some of them, they had yawned before, and for some of them, they hadn't yawned before. Right? So is that what everybody came up with?
Yeah.
Yeah. Okay. So the first thing is that. So how did they design the investigation? They basically divide them into groups. For one of the groups, they yawned before they put them in a room, and for the other group, they didn't yawn before they put them in a group. And then they looked at whether these people yawned or not. The next thing was, what steps did they take? Well, that's basically it, right? They just separate them into groups, apply a stimulus to one of the groups, and then see what happens. Now, what did they find? What did they find?
There was a 4% increase.
Okay, so there was a 4% difference in the numbers between those that had received the stimulus and those that hadn't, right? So that means basically divide them into groups that for those who yawned and for those that didn't, weren't exposed to the yawn. For those that were exposed to the yawn, you had that 25% of them ended up yawning. And oh, there you go, Mario. So then for those that weren't exposed to the yawn, you had 29% of them that, what? Backwards, I have it backwards. 29% of those that were exposed to the yawn ended up yawning, and 25% of those that weren't exposed to the yawn didn't yawn. All right, so what does this mean? Is yawning contagious or is it not contagious?
They said it was contagious.
They said it was contagious. Okay, so maybe some of you are a little bit reluctant to conclude that it's contagious because a 4% difference is not necessarily that large, so it might be not significant enough. We're going to see methods in which we can actually determine whether something is significant or isn't significant. For now, we just have to trust them in saying, okay, if they say that it was significant, they drew a conclusion, and that conclusion was right. That's what we're going to assume for now. Okay. So what they showed is that yawning is contagious. Okay. Now, are these results a proof of causality or association? And if they are proof of causality or association, how do you know that? Who says causality?
I would say causality because it's one yawn leading to another. Like it's one yawn like creates the other in the way.
Creates the other, yes. So basically what happens is what we're measuring here is if yawns are contagious, but that in its essence is causality, because what we're trying to determine is if I see somebody yawn, does that cause me to yawn as well, right? So the whole point over here is to show causality, right? Now, how do we know that this is causality and not just association? How can we be sure that the results that we got actually show me that that one yawn causes another?
Because the people weren't originally yawning.
Mm-hmm.
Like it took a yawn for them to yawn.
Yeah, okay. So were the people the same? Were the people the same, or were there different people? Or how do you know that, like, how do you know that it was the yawn that caused the other yawn and not something else? Mm-hmm. Wow. Okay, does anybody know?
That's what they tell us in the video, no?
Because they tell us in the video. Yeah, well, that's the easy answer. But if you wanted to conduct the study yourself, how would you be sure? How would you be sure that it is the yawn that causes it and not something else?
They had a control group.
They had a control group. So basically what they did is that they made it so that the only difference between the two groups was whether they had been exposed to a yawn or not. Does everybody understand that? Yeah. So like basically what they did is that they divided the group at random into the people that were exposed to a yawn and the people that were not exposed to a yawn. And so the only difference between the two groups was that they were exposed to a yawn. And because of that, they can say, okay, well, the only difference between the two was whether somebody had yawned in front of them. And so if I see a difference, that difference can only be caused by whether they saw a yawn or not. Does everybody get that? Does that kind of make sense?
Yep.
Yeah.
Yeah. So the big thing over here is to say the only difference between the groups was whether they had been exposed to a yawn or not, right? So for example, it wouldn't have been the same if I had said, okay, you know what? I'm going to yawn in front of the people that get there at 6 a.m. and I am not going to yawn in front of the people that get there at 2 p.m. Right? And then I find that for these people, there's a 29% chance of yawning, and for these, there's a probability of 25% of yawning. Of course, these results would not show me that yawns are contagious. What this shows me is that maybe people that were there at 6 a.m. are going to be more likely to yawn, right? So what's important is that you assign people to one of the two groups at random, and then you can then you're able to measure what the differences between those two groups are going to be. Does that more or less make sense for everyone?
Mm-hmm.
Yeah. Okay. All right. So what the Mythbusters did in this particular episode is what we call an experiment. And this is the only way that we have to collect data in a way that it shows us causation. So I'm just going to define the different elements that there is to an experiment. And then I'll provide the examples that correspond to it in the Mythbusters example. And we're going to see how they're important and why these allow us to determine causation. Okay, so what? Okay, there you go. So the first thing that there was a research question, right? So the first thing that I need to come up with if I want to conduct an experiment is a research question. And a research question is basically just the question that I'm trying to answer. So this is the question to be answered by the experiment. Okay, so when I talk about the research question for this experiment, that was just the question that they were trying to answer, which was, is yawning contagious? Right? Now, this particular research question is a more philosophical question, right? So it's basically just saying, okay, what's going on? And this leads to a more specific statistical question that we address during the experiment, which is, are people that see other people yawn more likely to yawn? Right? And so this is a little bit more concrete. So what are we comparing specifically? People that see someone else yawn versus people that don't see somebody else yawn. And we're looking at an outcome, which is whether they themselves are going to yawn. Does everybody understand that? Do I have any questions? Okay, Mario and Sean, you have your hands up. I am going to ask you to put your hands down, and then if you have any questions, you can raise your hand. Thank you. The second part of an experiment is going to be the subjects. So that just means the people or the objects on which the experiment is conducted. And so the people or objects on which the experiment is conducted. Okay, so that's not too difficult. The third element over here is the treatment. And this is crucial when we have an experiment. So the treatment is essentially the stimulus that you're putting on one or another of the groups, right? So this is the procedure that is assigned to a group of subjects. Right, so the treatment is essentially the thing that is making that group different from the control group or from the group that you have done nothing to. So in this case, the treatment was to yawn in front of them. Right, so this is the thing that you are doing specifically to identify whether there's a difference between two given groups. The group that is exposed to a given treatment is called the treatment group. Which is just the group of subjects that receive the treatment. And the other group, the group that doesn't receive the treatment, is called, as Alex said just earlier, the control group. So it's the group that does not receive the treatment. The sixth part of an experiment, and this is one of the most crucial parts of conducting a proper experiment, is random assignment, which is the fact of subjects being randomly assigned to either the treatment or the control group. Oops. Random assignment. Now, random assignment is super important because this is what guarantees that the reason that we're observing a difference between two given groups is the treatment and not something else, right? So what we're doing with random assignment is that we're saying, okay, well, a population is composed of a variety of people that have a variety of properties. And what I'm doing by randomly assigning these people to one of the two groups is to put them into one bin or another at random. And I am distributing all of that randomness equally between the two groups, the treatment group and the control group, right? And what happens when I distribute people equally between those two possibilities is that now all of that randomness that I see in my population is evenly spread between the two of them, so that I can assume that any significant differences that I observe between the two groups are actually caused only by the treatment. Does everybody understand that? Because that's like the crucial part over here. Who understands this? Please raise your hand.
Wait, can you repeat that quickly?
Okay. So the whole point of random assignment is that if you have, so you have a population that has a lot of variability, right? So in your population, let's say the population of Montreal or the population at a college or the population of people that were exposed to yawning over here, you have a lot of different possible properties. So like age, race, sex, whatever it is.
Yeah.
And by randomly assigning them to one group or another, you're distributing all of that randomness equally between the two groups, right? So that the two groups should be more or less the same because they have the same level of randomness through all of those possibilities in one or the other, right? And what happens with that is that you're basically creating two groups that are essentially the same, and then only to one of them are you applying a treatment. So what that allows you to do is to say, okay, if there's a significant difference between the two groups, it can't be just out of chance. It has to be the treatment that I applied.
Oh, okay, I get it.
Yeah, okay. All right, is that okay for everyone? Or does anybody have a question about that? All right, so then the next thing that we can talk about is the outcome, which is essentially the variable that the treatment is meant to influence. So in this case, the variable that the treatment was meant to influence is whether somebody yawned, whether somebody ended up yawning or not, right? So yawn, yes or no. All right, and then you have the statistic. And the statistic is basically the number that is computed or calculated based on that outcome. So this is the number computed based on the outcome, right? So in this case, the statistic, the number that we computed was the proportion of people that yawned. Okay. And so what we do is we measure an outcome, then we compute a statistic, and then the statistic is what is actually going to allow us to compare two different groups. Does that make sense for everyone?
Yeah.
Yep.
Good. Okay. All right. So I already explained all of the parts. So I think the most important part over here is the fact that we have to randomly assign individuals to one group or the other. So this is going back to what I explained just earlier. I'll go back to that slide, but going back to what I explained earlier, if you don't assign them randomly, so for example here, if I just choose the first ones to beyond that and then the last ones to not beyond that, then it's not going to be, my experiment is not going to be representative because I will have introduced the bias into my experiment, right? So by doing random assignment, I am going to avoid all of that bias that I can introduce into an experiment. All right, so the next thing, yeah. Do I have any questions about this, or is everyone okay with this? Johanna and Carolyn, you have your hands up, but I'm guessing that's just, there you go, okay. So what I'm going to do now, okay, so experiments are the only way that we can show and be for sure, and be 100% sure of causation, Okay, so if we want to be 100% sure that something causes something else, we have to use experiments. That is the most direct way in which we can show causation between two variables. Now, of course, experiments are not always they're not always the most appropriate way of data collection that we have, and so we have to look at some other options. So I'm going to introduce the next possible case, which is called observational studies. Okay, so this is observational studies. And in order to study observational studies, and here I really hope that the data copies properly, I'm going to have all of these data that I think you may remember or may not remember. Oh, there you go. Okay. So this was data that was collected on the stick figures a while back.
Should we copy this down?
You don't have to copy it down. You already had it in your tables. It's just a matter, I mean, all of this is going to be on YouTube anyway, so you can just go back to that if you want to.
Sure.
And then here, no, not that. Okay, so does everybody remember what I'm referring to? So these are, on the first day of class, I think I had you collect some data on stick figures, and this is the data that you had collected. So it was data on the name of each one of the stick figures, the GPA. This was, draw here. No. Well, after all of that. Okay, you get it, I guess. Okay, there you go. I'm just gonna keep it like that. So this is data on the name, the GPA, the number of friends on social media, the height, the sport that they played, and the type of shoes that they wore. So either sneakers or flip-flops. Okay. Now, what I want to ask you over here is, so you agree with me in this case, this is just an observational study because all that we've done is we've looked at people on which data have been collected, and we're just looking at that data, but we really don't have, we haven't introduced any kind of treatment onto our group, right? So we're just looking at data that is already there. So what I'm going to ask you to do is to determine whether there is one of the variables that you can see over here that might be associated with the number of friends that each one of these stick figures has on social media. So the question over here is there a variable that seems to be associated with the number of friends that somebody has on social media? Okay, so I'll give you just 2 minutes to examine the data and see if you can see any variable that would be associated with the number of friends on social media. Okay, does anybody see a variable that might be related to the number of friends that somebody has on social media?
I mean, usually, what I saw is like higher GPA. There's a high, people with higher GPAs have more friends.
Okay, and people with lower GPAs have fewer friends, according to this table as well, right? Can I see a show of hands for those of you who found the same? Okay, several hands up, good. So yes, so that's what I was going for. You have that people with very high GPAs, so for example, 3.98 are associated with a high number of friends on social media, whereas people, at least like the people that had the lowest GPA are associated with a smaller number of friends on social media, right? So what we have is that number of friends seems to be associated with the GPA. Okay, so now I'm going to destroy that. Okay. So what we have is that the number of friends, so the number of friends seems to be associated with the GPA. Now, of course, it doesn't seem clear that one of them is causing the other, right? It doesn't seem clear that if you have more friends, then necessarily you have a higher GPA. It's not because you have more friends that will automatically make you, or even make you more likely to have a higher GPA. In the same way, it's not clear whether having a higher GPA would make it so that you have more friends, right? So there's not like an obvious link that might relate friends and GPA in one way or the other. What I do want to ask you is if you think that there might be another variable, not number of friends and not GPA, a variable that was not on the table that could affect both the number of friends on social media and the GPA at the same time. So one variable that could be responsible for the values of both of these.
Like what school they go to?
What school they go to. So maybe, I don't know. If the school is better, if the school is better, then they also have more students. Is the idea there?
Yeah, basically.
All right. Okay. So if the school is better, then maybe there's more students, but that doesn't necessarily mean that at the individual level you're going to have more friends, right? So that might be like a general statement that you could do based on averages for the school, but it's not really going to change whether one single person has a higher GPA or not. Does anybody have any other ideas?
Maybe the number of hours that they play their sport.
Maybe the number of hours that they play a sport. So if they have, can you explain the link to me? I'm not seeing it.
Like if they're playing, because they all play sports, so like if some of them are playing like for longer hours, it might affect like the amount of time they have to study, so their GPA.
Okay, yes, but now we're looking at the link between GPA and friends, right? So we're looking at how one variable could affect both the number of friends and the GPA. So if we're thinking about the fact that more hours spent training mean a lower GPA, then also maybe more hours spent training would mean
too.
would
less
mean
time to hang out.
Less time to hang out with friends. So the link on both of them is not necessarily clear, right? Because what we're seeing is more friends means more GPA.
Okay.
Okay, anything else? According to you, what kind of people are going to, like, what could characterize people that have more friends and a higher GPA?
They might study with their friends.
Okay, so they might study with their friends. So that's a possibility. Maybe if they're having productive friendships, that could be a possibility. Anything else? Now that's based on an assumption. So like that's the reason that I don't go that in depth into the possibility that maybe they're studying with friends is that we're making a big assumption. We're just assuming that if people have friends and they're studying together. I don't think that's necessarily true. So I'm going to go with just leaving that on the side for now. So one possibility, and again, this is just, we don't have any information on it. So we're just, speculating here. We're all trying to figure this out. Could be to say, okay, well, maybe if somebody is more confident, they're going to have a wider friend network, right? So they're going to have more friends. It's going to be easier to make friends, to socialize, maybe because they're confident. And if somebody is more confident, then they also might be, they also might perform better at tests, right? Which might lead them to have a higher GPA. Does everybody understand that? Yeah. So this could be one possibility. There's a bunch of other possibilities. This is just like one example, but essentially what this is called is a confounding factor, which is to say one variable that might be affecting two variables in the same way, in such a way that those two variables seem to be associated to one another. Okay, so that's what we're doing here. We're just identifying a third variable that could be responsible for the other two. Is that okay for everyone?
Yeah.
Thank you. Okay, so because with observational studies, we might have these variables over here, these confounding variables, we can't show causality necessarily, because we might have that the association between two particular variables might be due to a confounding variable, another variable that is affecting the two variables at the same time. So I'm just going to put that remark over here to say that when we're talking about observational studies, we might be able to study association, but not causation. Okay, so observational studies allow us to determine association but not causation, because we can't identify whether the differences are occurring there just naturally because two things are caused by something else, or whether there's actually one of them that causes the other. Okay, actually the statistical tools that you need in order to show causation when you have observational studies are super complicated. We don't even get to that in this class. Okay, so all right. Now, this doesn't mean that we don't necessarily want to use observational studies. Sometimes we will want to use observational studies because it might be difficult to do experiments. So, why use observational studies? Okay, and to explain why you sometimes might want to use observational studies, I'm going to ask you why you could not use experiments in the following cases. So suppose that you have the following possibilities. So you have to answer the following question, which is why wouldn't it be possible to perform experiments to answer the following questions? So the first question that I want you to answer this for is, does smoking cause lung cancer? Can anybody explain to me why it is not possible to do an experiment in order to answer this question? And maybe a way to think about this is to first think about how you would conduct an experiment in this case. So how would you conduct an experiment, and then why couldn't you do that experiment?
Well, to conduct it, wouldn't you have to have like people smoke until they have cancer?
Basically, right? So basically you would have to have two groups of people. Tell one of the groups, okay, you don't smoke, and the other group you'd have to say, okay, you smoke, right? So then you would have like those two groups, and then you would wait and see until some of them get cancer, and then you would say, okay, well, these seem to have cancer and these don't seem to have cancer. But of course, it is not really ethical to make people do something that might make them sick, right? So this is a problem because of ethics, right? If you have a chance that you will make your subject sick, or that you will put them at risk in any kind of way, then your experiment is not, you should not do that experiment. Okay, so that's just a matter of ethics. For the next one, does drinking water from Mars keep you healthier than drinking water from Earth? Anyone? Why couldn't I do this experiment?
Because you physically can't do it.
Well, you can get water from Mars, but it's gonna be a little bit more challenging.
Oh, okay. No.
In particular, what's gonna happen? How much do you think a glass of water from Mars is gonna cost?
Couple million.
Couple million, yeah, probably more. It's ideal. Maybe it's not even sold, right? So unless, not even unless, there's really no way that you can buy that, right? So this experiment would be impossible because you don't have enough resources so that you could pick half of your subjects and give them water from Mars and then see what happens, right? You have cost limitations in this case. And the last question is, do people with higher IQ scores have better R scores than people with lower IQ scores? According to you, why could we not do this experiment? Why couldn't we use an experiment in order to answer this question? Okay, if you wanted to do an experiment based on this, how would you do your experiment? Alex, is that your hand up?
Yeah.
Okay, go.
Well, basically, we'd have to take a large group of people
Mm-hmm.
with higher IQ scores, a large group of people with lower IQ scores. But the issue is that IQ and R scores are both very case specific to certain types of things, because IQ scores vary depending on type, and R scores vary depending on where in the world and stuff like that.
So there's that, but imagine that we were talking about just John Abbott College, and we're trying to determine whether IQ scores make you have a better R score at John Abbott College. It's still not feasible. Is there any way that I could randomize my experiment? Yeah, Alex, your hand is still up.
Oh, sorry, no, I meant to take it.
Okay.
Did it have to do with program? Like what program you're in?
So it doesn't necessarily have to do with program. The thing is that, IQ score is not really something that you can assign. You can't really just say, okay, like half of this group, I'm going to give a high IQ score, and then the other half, I'm going to give you a low IQ score, and then I'm going to see what happens. It doesn't really work like that, right? So if I wanted to study whether IQ scores give you a better R score, I would have to do an observational study. And then I don't know necessarily if the R score would be caused by the IQ score. Now, what happens is that in this case, there's no way of randomizing it. There's no way of having a control group, because I can't just assign one of the groups to have a high IQ score and the other one to have a low IQ score. It's not something that I can assign. Does everybody understand that?
Yeah.
Yeah. So it's not really something that I can assign. So that's a problem of feasibility. Feasibility. Okay. So these are like the three main things that we need to consider when we're doing an experiment. If it's possible to do an experiment, then we'll try to do an experiment because it will allow us to determine causation. But in some cases, we can't do an experiment and we still have to come up with the data, which is when we end up doing observational studies. Okay. Now, for our next class, I'm going to post, as soon as this class is done, I'm posting an assignment. It's a small homework on Leia. And what you have to do is basically for 6 or 7 scenarios, determine whether you can do an observational study or an experiment. If you have to do an experiment, then you should explain just the main traits of how you would conduct that experiment. And if you have to do an observational study, you have to explain why you couldn't do an experiment, right? So maybe there's an ethics problem, there's some cost limitations, or there's some feasibility problems there, okay? So it's just basically to say which one of the two you use and why you have to use an experiment or an observational study. And if you're conducting an experiment, how would you conduct that experiment? Does anybody have any questions about that? Okay, so this is the same as usual, graded on completion. I will make you submit it by Thursday, and then afterward, I'm just going to be reading your answers throughout the weekend. Is that okay for everyone?
Yeah.
Yes.
Have any questions about anything, or is that